So I did questions 1, 4, and 9. And so, like, for number 1, if, like, for concave up, say, like, you have interval, like, a and b of f's domain, if the graph of the function curves up, then that makes it, like, concave up. And the average rate of change of f, it will be increasing. For concave down, if the interval of the domain, if it's curving down, then that's what it's concave down, and the average rate of change of f is decreasing. And so I have a graph here. This is concave up, and then this is concave down, because this is curves up and these both curve down. And like this is concave up but increasing, and then this is decreasing, and then this one is decreasing, and then this one is increasing for concave down. And then an inflection point is like, say you have a, f of a on the graph. F is like the inflection point if the concavity changes from like up to down or down to up at this point. So here's an example. So right here it's concave up, and then it changes into concave down. So the inflection point is right here because that's where it's starting to change, between concave up to concave down. And for the question number 4, the first one, I just factored it normally. Since there was a greatest common factor of 3, I pulled that out, and so that went out in front, so it was 3x squared minus 9. And since I could factor 9, I factored it down to x plus 3, x minus 3, and it couldn't be factored after any more of that, so that's my answer, 3, the greatest common factor, on the outside, then x plus 3, x minus 3. For the second part, you have problem x squared minus 6x minus 16, and I used the grouping method to like solve this. I used grouping because there wasn't a greatest common factor in this, and so I said x squared plus 2x, I grouped that, and then negative 8x minus 16, because positive 2 and negative 8 equal the middle number, negative 6, and so I found a common term between these, and so the common term in the first group is x, so x on the outside, x plus 2, and then the common term over here was negative 8. So I pulled that out in front. And then I put them back together down here, and I found the common term between them, which was x plus 2. So then I took out x plus 2 and was left with x plus 2 and then x minus 8 for my answer. And then for number 3, we have 2x squared minus 5x minus 12. I used grouping as well for this one, just because there wasn't a greatest common factor. And so I was left with 2x squared plus 3x plus negative 8x minus 12, and positive 3 and negative 8 give me my negative 5. And so I found a common term between the two, and the common term in this one was x, and then the common term in this one was negative 4. So I pulled the x out in the negative 4, and so I was left with x, 2x plus 3, and then this one was negative 4, 2x plus 3. And so I came down here and I put them back together, and the common term was 2x plus 3 for this one. So I took that out, and for my answer I was left with 2x plus 3, x minus 4. And then for question number 9, a degree is a unit of angle measured where 1 degree corresponds to an arc length equal to 1/360th of the circumference of the circle centered at the vertex of the angle. And then a radian is a unit of measure where 1 radian corresponds to an arc length that's equal to the radius of the corresponding circle centered at the vertex of the angle. And so I have how you solve how you go from degrees to radian and then radians to degrees. And so for degrees to radian, you would use this equation, pi over 180, and then you would multiply that whatever amount of degrees you have. So like say, for example, you had 200 degrees. You would multiply that by pi over 180, and then that would give us down to 10 pi over 9. And then I reduce that down to 3.49 radians. And so that's how you get from degrees to radian, is just multiplying your degrees by pi over 180. And then to get to vice versa, to get radians to degrees, you would do 180 over pi multiplied by the radians we have. So it's kind of like the equations between these two are like just like flipped. So so say I had 4 pi over 9 radians. I'm going to multiply that by my 180 degrees over pi to be left with 4 pi times 180 degrees over 9 pi. And then I'm going to multiply those, which is going to be 720 degrees pi over 9 pi. And then my pi's will cancel out and leave me with 80 degrees.